What is colour? What do we actually mean by colour? And how does it affect laser treatments of tattoos? Well, if you look at white light, it's basically all the various colours mixed together. In fact, white is not actually a colour at all. There is no wavelength for white. It's all the other wavelengths all mixed together. Individual colours that we may see, like red, green or blue, are basically just the white light with the other wavelengths subtracted out. So, if you fire some light at an object, what is the probability of that object absorbing that light? Well, it depends on the cross-sectional area of the atom and the absorption cross-sectional area sigma. The probability of this atom absorbing that photon is just the absorption cross-sectional area, sigma, divided by the total cross-sectional area of the whole atom. So knowing this, we can now figure out the probability for various types of light in various atoms. If you have a red photon, for example, and it's encountering this particular atom, and the sigma cross-sectional area is relatively small, then the probability of this atom absorbing that photon is also going to be pretty small. If we then fire a green photon at the same atom, it may well have a larger cross-sectional area sigma, and therefore the probability of absorbing the green atom is significantly larger than absorbing the red photon. So now we know that the probability of absorption depends on the cross sections. Let's look at what this means in reality. Let's fire a blue photon at this atom. Well, that's a big cross-sectional area for the absorption, so it's highly likely it will be absorbed. This green atom, a green photon, is also likely to be absorbed. But this yellow photon is not so good, so it probably will not be absorbed. This orange one, maybe not so good either. And this red photon is unlikely to be absorbed because the cross-sectional area for absorption is so small. So this atom, or collection of atoms in this in the real world, is going to appear to us to be a reddish colour because it doesn't absorb the red photons and it doesn't absorb too many of the orange or the yellow photons. But the blue and the green photons are much more likely to be absorbed, therefore those colours will not appear when we look at the object. That's really how a colour of an object is determined, by the photons it absorbs relative to the photons that it doesn't absorb. So let's look at some laser energy. In this case we've got a red beam and it encounters this atom, and these are the cross-sectional absorption areas for these various colours. So we can see that there is reasonable absorption for the orange and the green and the yellow and the blue, but the absorption cross-section for red is pretty small. So the chances are that, that this atom will not absorb too much red light. Whereas a green photon, you can see here that the situation changes significantly. The red cross-sectional area is relatively large, as is the yellow and the blue, but the green cross-sectional area is quite small in this case. So again, it probably will absorb some of this, it won't absorb most of this photon or photons, and therefore will not get much of a reaction with these atoms. And then you get a situation like this where you have a laser photon and the cross-sectional areas are small for all these colours. Therefore there's likely to be very little reaction to this particular laser energy. The only way you can improve upon this is if you increase the fluence, or the number of photons encountering these atoms. By doing this, you're firing more photons per unit time, and therefore the chances of something being absorbed increase. Therefore you're more likely to get a reaction in this situation. So let's look at tattoo ink colours. A red ink is red because it absorbs most of the coloured light that falls on it except red. That's why it appears red. So it absorbs all the blue and the yellow, orange and green to some extent, but it will actually absorb some of the red photons as well, but to a lesser extent. It all depends on the absorption cross-sectional areas and the geometrical or physical areas of the atoms and the ratios for that wavelength, for that color of photon. And it obviously means that it changes for different photons or different wavelengths. So this explains why some tattoo inks respond very well to some laser wavelengths, while others don't. This is why sometimes we have to change our laser wavelength when treating multicolored tattoos. I hope you found this interesting, and hopefully it explains why in some cases the laser treatments work well, and in other cases it just doesn't. It all comes down to the absorption cross-sectional areas. If they're big enough, then they'll absorb. If they're not big enough, then they won't absorb. If they don't absorb, you don't get any heat. If you don't get any heat, the reaction isn't going to happen. You can find more videos and animations like this on our YouTube site, and also in our blog, which is here. Thanks for listening.